Hi everyone, today we will continue with our triangles. Now in this chapter we will explore the properties of a triangle and study some facts about the different types of triangles. Now many everyday objects are triangular, and here we have a few examples. And we have a slice of pizza, we have a pyramid over here, you can see the triangular shape over there, and we have a hue sign over here. Okay, so our triangles are quite unique in that they are very powerful, and their strength comes from its shape and its three sides. They are very common and simple to apply in everyday life. Now we start by refreshing your memory of previous knowledge of triangles. We start with the sum of the interior angles of a triangle. Now in the following figures I measured each angle with my protractor, and what did I find? First I started with angle A, and I can see angle A is equal to 40 degrees, B 50, and C 90. Then I add up all three, and the sum of the three equals to 180 degrees. Okay, look at the next figure over here. It's a different shape to this one, but P is equal to 37 degrees, Q is equal to 28 degrees, and R is equal to 115 degrees. And the sum of these three angles again is equal to 180 degrees. And the third one, D 60 degrees, E 60 degrees, and F 60 degrees. Add them and I get 180 degrees again. So all of them different sizes, but the angles, the sum of the three angles always add up to 180 degrees. And I say here, if measured correctly, you will find that each time the sum of the three angles adds up to 180 degrees. Now we can also give names to our triangles according to their sides and according to the sizes of the angles. Now I classified this three now according to the sizes of the angles. Here I have one angle of 90 degrees, and I call this a right angled triangle. One angle of 90 degrees and two less than 90. But because of this one, we call that a right angled triangle. Okay, the next one. Here we have one angle that is an obtuse angle. Angle R is equal to 115 degrees, right? An obtuse angle, and we call this an obtuse angled triangle. The third one. All three angles are less than 90 degrees. 60, 60, and 60. They are acute angles, and because of that we call this an acute angled triangle. Over here we have the classification according to the angles again. Now our first conclusion now was the sum of the three interior angles of a triangle is always equal to 180 degrees. My first example, all the angles are acute, or all the angles are less than 90 degrees. So we call that an acute angled triangle. Here we have one angle that's in between 90 and 180. It's an obtuse angle, and from there the name obtuse angled triangle. Then the last one, we have one angle here of 90 degrees, and we call that a right angled triangle. Right. So we can also classify them according to their sides. First of all, you can see here I have a triangle. All the sides have different colors to show you all three sides have different lengths. What do we call this? Or we call it a scalene triangle. It's a scalene triangle. And the next one, two sides are equal in length. The two in blue, they are equal in length. Here we have one that's a different color, but this two, they are also marked the same to show you that these two sides, they are equal in length, right? And we normally mark them the same, and we call this an isosceles triangle. Then the last one, you can see all three sides in yellow. So all three sides are equal. That's why I actually mark them all the same, and we call that an equilateral triangle. So scalene, all three sides have different lengths. Isosceles triangle, two sides have the same length, right? And we normally mark the two with the same length, with the same marks. Then the third one, all three sides are equal. We all mark them all the same, right? So we know now that the sum of the three interior angles of a triangle is always equal to 180 degrees. So here I have the steps again to find the unknown angle. So in this figure over here, this is our unknown angle. Here is this 80 is given the given angle, 55 is the given one. So calculation of an unknown angle without a protractor. So in triangle ABC, we can see now angle B is 80, C is 55 degrees. So find the size of angle A. Because all three angles add up to 180, we write it out like this. Angle A plus 80 plus 55 is equal to 180 degrees. Reason always, three angles of triangle. The next step, we subtract the 80 and the 55 from 180 degrees, and the answer is equal to 46 degrees. Right, three angles of a triangle, or the sum of the three interior angles of a triangle, is always equal to 180. Here we have an exercise, and we start. Given 63 degrees, that angle D, that is given to us, 57 degrees, that's given to us. The only unknown angle here is X. We know the rule, X plus 57 plus 63 equals 180, and the reason, three angles of a triangle. Right, so in the next step, we will subtract 57 and 63 from 180, and the answer equal to 60 degrees. And our next one, right, we have this triangle over here and that one over there. In this triangle here, we have two unknowns. So it's not possible, although we know that 33 plus x plus y is equal to 180, at least we must know the size of one of them. So the only way to do that is to start from this triangle over here. Now we know we have a common vertex over here. So we know that this two, they add up to 180. Why? Adjacent angles on a straight line. So we start by finding the value of x first. So we start over here and we say x plus 100 is equal to 180. Y, angles on a straight line. And in the next step, we will subtract 100 from 180, and your answer is equal to 80. So now we know that this angle is 80. Okay, Where can I write the 80 over here? 80 degrees. So we have two known angles now. So it's easy to find the third one, because we know that y plus 80 plus 33 is equal to 180 three angles of a triangle, or the sum of the three angles of a triangle is always equal to 180. I write it out like an equation. Y plus 80 plus 33 equal 180, three angles of a triangle. And in our next step we subtract, and in the last one we have the answer. So y is equal to 67 degrees. And once you add up 67 plus 33 plus 80, you must get 180 degrees. Next one. You know that this angle, that angle, and that angle must add up to 180 degrees. The sum of the three angles of a triangle. You will start with your equation. Z plus 55 plus 64 plus 34 is equal to 180. Right, so we have it over here, all equal to 180. Reason in between brackets, three angles of triangle. Next step, we subtract the given values from 180. Right, so Z is equal to 180 minus the 34, minus the 64, minus the 55. And it's equal to 27. So we have 27 over here. 27 degrees. Now, although I'm not asking for the value of F, the angle F here, I just want you to look at it. This F here, okay, F is equal to Z plus 55. Right, it's equal to Z plus 55. And it's equal to 82. If you test your answer, then 34 plus 64 plus 82 must equal 180 degrees. Right, three angles of a triangle, the sum is always equal to 180. Now look at our next one. In this diagram here, AB, this line, is parallel to CD. Immediately, we know that here we can make use of our corresponding angles, our co-interior angles, or alternate angles. Right, so we start here with X. X and which other angle form a pair? And I can see X and 53. Right, X and 53, they are corresponding angles. From the parallel line to the, and from the parallel line to the, and what do we call this line again? The transversal. So from the parallel line to the transversal, from the parallel line to the transversal. Both of them on the right hand side of the parallel line, and both of them above the transversal, corresponding angles. They are equal. So we start. So X is equal, you see here, X is equal to 53 degrees. Y, corresponding angles. So we have X now, 53 degrees. Now we can find Y, because we know that we have a common vertex here and three angles, when they are adjacent, add up to 180. Right. So we start. 53 plus 44 plus y is equal to 180. Angles on a straight line. And in your next step, you subtract the 53 and the 44 from 180, and your answer is equal to 83 degrees. 83 degrees. Now we move to Z. There are two different methods to get to Z. Z and 44. You see there? Z and 44. Z is, there we have the two parallel lines. Right? And this is the transversal over here. One is on the one side, one is on the other side. This angle from the transversal to the parallel line, and we have from the transversal to the other parallel line there. So these two angles, they are alternate interior angles because they are in between our parallel lines. So we start with the shortest method. Z is equal to 44. Right. Why? Alternate angles. You can also use the other one, that the three angles of a triangle is equal to 180, and you can subtract the 53 and the 83 from 180. So, or you can use this one, the shortest method, or you can go for the long method. Right, 53 here plus 83 plus Z is equal to 180. This time the reason is three angles of triangle. And we will continue by subtracting the 53 and the 83 from Z, and the answer is equal to 44. Exactly the same answer as that one over there. Right. And we get to the next one. Here we have two parallel lines, and we can still make use of corresponding alternate or co-interior angles. Or we can make use of our three angles of a triangle or adjacent angles on a straight line. We start with X. And you can see that here we have a triangle, and the three angles of a triangle equals 180. And we only have one unknown angle, so it's quite easy. We just subtract the 44 and the 72 from 180. Right, so X plus 44 plus the 72 is equal to 180, three angles of triangle. So X will be, then we subtract in the next step, and X is 64. So we have X now is 64. Right, 64 degrees. Next one. I can see a pair of corresponding angles here. I can also see a pair of alternate angles here. Right, where do we start now? We start with Y. You see there? From the parallel line to the transversal, and X is from the parallel line to the transversal there. So these two angles, they are alternate angles because they are also in between the parallel lines. So alternate interior angles, right? The interior. So we write it down. Y is equal to 64. Right? 64 degrees. Y alternate with X. Alternate with X. Right. So the next one, Z over here. There are two ways to get to Z. The first one, from the parallel line to the transversal, from the parallel line to the same transversal. That is what we call corresponding angles. Right? They are corresponding angles. and they are equal. So Z is equal to 72 degrees, corresponding angles, right? Or the long method, these three angles here, they add up to 180 because they all have the same vertex and they are on a straight line on the same side of the straight line. Right, so you can use this one also. 44 here plus 64, the 64 over here, plus Z is equal to 180 angles on a straight line. So Z is equal, and we subtract the 44 and the 64 from 180, and Z is equal to 72 degrees. Right. Here I have the same exercise again. I want you to work on your own. If you don't understand any of these, you can just refer back to my explanations. Now, please subscribe to my channel and you will receive at least 3 lessons every week. Thank you so much.